Okay, so for our presentation today, I forgot to record the beginning of it. And here's what we had at the beginning. We were talking about how we had gone over population modeling last time, and we had talked about habitat being one of the issues with understanding what is going to occur in a population, or why population dynamics are the way they are because of the habitat. And when we're looking at habitat, and we're trying to actually figure out not only where they currently are, but where they potentially could be, but we haven't seen them yet, we would do something called a habitat suitability model. And in this case, what we're taking is the occupancy information from occupancy studies, and we're pairing them with the assessment of the environment that they were located in. And in order to do this, you have to use some geographic information system software that allows you to input the GPS points for the individuals, and then add some more information in from the U.S. Geological Survey or the National Oceanic and Atmospheric Association and weather data to understand some more specifics about what type of environment they're actually located in. The habitat models are not only identifying current habitat characteristics, they can then be used to create a population model that predicts why the species is found in certain locations. You can also take that information and extrapolate it and predict where suitable areas might be. And this can be locations where you haven't actually seen the species before, but might be areas where you want to look for them. And predicting suitable areas is also important for when we have a species of concern and wildlife managers are trying to manage the land that their wildlife is on. Doing a habitat suitability analysis allows the managers to prioritize locations that need to be looked at in order to improve the situation for the wildlife. So for example, in these pictures here, we have a map of the sort of middle to southern portion of Florida. This is the area for the northern crested caracara, the bird up in the corner. It's a scavenger. It's a pretty large bird, and it's having issues with habitat loss. So we look at the map here, and we can see that the habitat suitability model has a core area in dark purple, and this is where we have actually, seen the individuals. And we also have it mapping out suitable areas at different distances from the core habitat. And usually the distance is inputted here as an important factor because of potential dispersal from the core habitat, expecting that the core population is the one that's most important, and we're trying to understand where they might go if the habitat is available for them. You can see how the colors are interdispersed with open locations, and that can be because of man-made structures or water structures. It is Florida. There's probably a lot of water available there, and this isn't a particularly water-loving bird. It's more of a scavenger that could be found in those wetland areas, but not specifically a fishing bird for lakes. Anyways, with this information, you can also add information about the population dynamics of the bird to the habitat suitability locations. and predict with the information you have on the population's growth rate and survival and fecundity, the probability of a certain percentage of decline in the population numbers based on where habitat is lost. So we have a bunch of different lines here, and each is related to the model that you see there on the map. So for example, the loss in the core area would be that bright pink line. And so if we have loss of habitat in the core area only, we're going to have the highest probability of the highest percent decline in the population. Whereas if there's no habitat reduction, that's that blue line pushed back further, to have a lower percent decline in the population, as long as the population still has that habitat that they currently have. So linking these two items together is something that you'll see we talked about later with the population viability analysis part of today's lecture. Other species are biotic factors that need to be taken into account for population modeling as well. In some cases, just taking a look at how the two populations' abundances cycle, as seen with the snowshoe hares and the lynx, is something that can be modeled and then used to understand other predictors between the populations that are, impacting each other's population numbers. Sometimes when we're looking at population modeling, things can be simplified or made more complicated depending on how we alter the population inputs, the N, abundance, the K, the carrying capacity, the S, the survival, or F, the fecundity. Those data inputs are usually, straightforward for the certain species that we want to look at. But when there's another secondary species that's having biotic interactions with the main species, that means that we're altering those data inputs by either directly changing the numbers based on what we see in the field. Like, for example, say we're looking at otters specifically, and we think that the juvenile otters are going to always have a 10% decrease in abundance because of eagle predation. That could be a simple mathematical equation to change the abundance without having to implement a more complicated mathematical function. It can be created more complicated if we put in other probabilities, like the eagles are taking juveniles, 10% of the juveniles, but only on years when it's raining a lot, and so that would put in different kind of probability factor for a population model, making it more complicated. So when we're looking at other species, the population models can be simple or complicated depending on how specific you want to get with the information you have. And it's going to be different, of course, for predation, for competition, and for diseases, pests or parasites. But all of them are still important and can even interplay with each other. So that can make it a situation that has to be teased out before a model can be created. So we've talked about a lot of the different limits to population growth. I think I've covered all of them. But you'll see that usually there's going to be multiple effects that are operating on the population simultaneously. And so as researchers and wildlife managers, it's important to make sure you can know as much as you can about these different factors to get the best idea of what is occurring with the population. And in this case, you would end up making your hypotheses on what you expect is the most important factors in the population. You can test it out with a population model and see if statistically that's true or not. And this helps us then rule in or out factors that we might want to take actions on in order to assist the populations. But overall, it's important for you guys to note that when you're looking at information about a certain species, you'll have to understand that if they are focusing on, say, the inbreeding issues with Isle Royal wolves, that's just one part of the situation, and they might not be considering, or maybe or may not be considering other factors that would also impact the population. So wildlife population dynamics for wildlife is usually answering something to deal with one of these 4 questions, making it either something where you would end up doing field studies to understand the population, or where you would be taking the population information and trying to predict what could happen in the future. All of these are considered, answering all of these questions would be something where you could create a population model. But what we're going to get into next is a population viability analysis, and that's focused more on what will happen in the future. And with that, you'll hear more about that on the rest of the lecture. That should be posted up under the conference section for today, Friday, November 13th. But just recall that when we're worried about wildlife, it's usually for us, we're more focused on them at the population level in order to understand them well and know how we should interact with them.